Welcome to a video on solving systems of equations in three variables, and this is part 1 of 2. A linear equation in three variables is a plane in 3 dimensions. So for example, if we take a look at the graph of x minus 2y plus 3z equals 6, this will be a plane in 3D. Let's take a look. And here is that plane. So when we have three equations with three unknowns, there are three possible results. Number 1, the three planes may intersect in one point, and if this is the case, the system is consistent and has one solution. Let's take a look at this case. So what we're seeing here is each plane is represented by a linear equation in three variables. So we're graphing three planes in space, and they intersect in a single point as we see here in black. And this is the case where we have a consistent system with one solution. The next case is that the three planes intersect along a line, or they're all the same plane. And if this is the case, the system is consistent but has an infinite number of solutions. Let's take a look at the case where we have three planes that intersect in a line. So here are the graph of the three planes, and they intersect in this red line. And since the line has an infinite number of points, the system has an infinite number of solutions. The other case is if you graph the three planes and they're all the same plane, and there would also be an infinite number of solutions. And the last case is when we have three planes that do not intersect, or they intersect with no common points, and this system would be inconsistent. Let's go ahead and take a look at that type as well. So here we see the graph of three planes in space, and there are no points where all three of the planes intersect one another. We can see that two planes do intersect, but all three never intersect in any one location. If you take a look at it here, you can see that the three planes never share any points. So those are the three possibilities when you solve a system of three equations with three unknowns. Let's take a look at how we're going to solve them algebraically. This method is very similar to the elimination method when we have two equations in two variables. It just takes a lot more work. So here's what we're going to do. Number 1, we'll select two equations and use the elimination method to eliminate one of the variables. Then we'll select two different equations and eliminate the same variable again. Then what we're going to do is take the two equations with two variables and solve the system of two equations using elimination or substitution. From this, we'll be able to identify the type of solution we have, if any. If there's no solution, we'll state no solutions. If there is one solution, we'll use back substitution to determine the value of the three variables. And if there's an infinite number of solutions, we'll state the relationship between the three variables. Let's go ahead and take a look at an example. Now what I like to do is identify each equation with a letter. So let's go ahead and call this equation A, this equation B, and this equation C. We need to pick two equations and eliminate one of the variables. And if you take a look at equation A and equation C, if we add them together, notice the x terms are already opposites, so the x variable will be eliminated. So let's go ahead and do that. We'll take equation A and add it to equation C. Again, notice the x terms are opposite, so that would add to 0. We have negative 3y plus 5z equals 13. And let's go ahead and label this equation D. So now we'll go back and pick two different equations and eliminate x again. So if we pick equation A and equation B, to eliminate the x terms, we want this to be negative 2x. So we'll multiply equation A by negative 2 and add it to equation B. So we're going to have negative 2 times equation A plus equation B. So multiplying equation A by negative 2, we'll have negative 2x plus 2y minus 4z equals negative 12. Equation B will stay the same, so we have 2x plus y minus 2z equals negative 3. We'll add these two equations together. The x terms are eliminated, and we have 3y minus 6z equals negative 15. We'll call this equation E. Now we're going to take equation D and equation E and solve them as if they were a system of two equations with two unknowns. If you take a look at equation D and equation E, notice the y terms are already opposites. So we can go ahead and add those together to eliminate the y term. Let's go ahead and rewrite these over here. Okay, so when we add these equations together, the y terms are eliminated. We have negative z equals negative 2. So now we know that z is equal to positive 2. Now what we have to do is go back and find the values of x and y. So our solution is going to be an ordered triple. So we have x, y, and then we know z is equal to 2. So using equation D or E, we can replace z with 2 to find y. Let's go ahead and use equation E. We have 3y minus 6 times z, but now we know z is 2. So it looks like we have 3y minus 12 equals negative 15. So we're going to go ahead and add 12 to both sides. That will give us 3y equals negative 3. Dividing both sides by 3, we have y equals negative 1. Now we still have to go back and find the value of x. To do that, we'll go back to one of the original equations. Since now we know y and z, we can determine the value of x. Let's go ahead and use equation A to determine the value of x. So we have x minus y, or minus negative 1 would be plus 1, plus 2 times z. Well, z is 2, so that'd be 2 times 2, or 4, must equal 6. So we have x plus 5 equals 6, x equals 1. So here's our solution to this system. As you can see, it's quite a bit of work, and it's also important that you keep your work organized. And that's why I recommend labeling each equation so you can keep track of exactly what you're doing at all times. Let's go and take a look at this graphically. Remember, each of these equations represents a plane in 3D. And this is the graph that we saw earlier. This point in black is the solution to that system that we just solved. Okay, we will take a look at two additional examples in the next video, one where there's no solution and also one where there's an infinite number of solutions. Thank you for watching.